Soy Carlos de Amazon Web Services. Antes de empezar, os quería dar, porque hay un pequeño error en el programa, la presentación de Six Rules for Growth, las 6 reglas para el crecimiento, es para la keynote que hago a las 6:15. Ahora lo que vamos a hablar es de mobile y IoT, Internet of Things. So, perhaps before I start, who speaks English and not Spanish? Okay. I'm sorry, you're the only one. So, are you okay if I continue in English, or do you prefer me to switch to Spanish? Who doesn't want to listen to me in English? I'm really so you guys have to fight, and I'll check the. Okay, got it. Good. So I'll continue in English, and if there's something, I'll get you in Spanish. No worries. So, I wanted to talk about those two things: mobile applications and Internet of Things, because what I see now, it's from the customers that are using Amazon Web Services, like people like Dropbox, Illumina, and so on. They are extremely closely related. That is, you don't do Internet of Things without mobile applications. And more mobile applications require devices. Like, I don't know if people here use things like a Fitbit or these kind of things. They go both hands in hands, right? So what I wanted to share you here is a couple of best practices and things that we see of customers doing both use cases. So before I start, I wanted to come back with an interesting study which gives you the statistics of people who never use what we call the desktop web. That is either a laptop or a desktop machine, right? And as you can see here, I mean, what we usually call the emerging countries, they have a very, very high rate of people that never use desktop web, that only use mobile devices. And it's even better if you look at it in this other study. So this one shows you the rate of acceptance and acceleration of technology adoption depending on countries, right? And it's interesting to see that the countries that we think that are more perhaps advanced in technology, like Europe and the US, are the ones that are the slower to adopt new technologies. And when I say slower, it's not about buying the latest iPhone or the latest devices and so on. It's about buying new or adopting new practices. Like if you look at how South America, for example, or even Africa or Asia is adopting mobile applications, it's at a rate that is way, way faster than what we see in Europe. You probably saw in Europe already in your conversion rates, if you have, for example, a startup that has both a mobile application and a desktop application, a migration of users to mobile applications way slower than in other territories. And this is something that we observe, I mean, not only across Amazon, but all the companies that are doing exactly the same things like us. So first, one of the main problems of mobile applications is the backend. And it's a problem because no one says it, right? We always see the application we have on our phone, but not the backend. And I can tell you that this story now, I've seen it, I don't know, hundreds of times. So it always starts like this. That is, I made a startup, they designed a nice application, they are very proud of the application, they release it. Customers love the application, but suddenly everyone wants to use it, and the backend crashes. And this is the real, not a revolution, but a call to action that has been acquired like 2-3 years ago, that mobile application not only needs scalable backends, but also highly available and durable, because you're going to store customer data on it, right? So I wanted to also talk a little bit about this company. It's not a startup anymore. It's Animoto. So they pioneered the activity of generating videos on demand. That is, you take some pictures or you take some videos and family videos and so on, and people store them, but no one edits them and create a nice thing. So that's their business. That is, you give them pictures and videos, and they are going to automatically generate a video for you with music and so on. Magisto is another customer running on Amazon that is doing exactly the same thing. So it happened to them exactly the same thing. That is, they were featured in Facebook, what people say like being tech crunched, because you appear in this very popular news site and suddenly everyone is using our application. And what's interesting to see here is the scale. It's a bit old, it's in 2008, but It's in terms of days, right? And you see that in just 3 days, they went from 40, let's say 50 nodes, 50 servers, to 5,000 servers. And this is something that if you try to transpose it to the classic ways to do things, you definitely understand that it's not possible to do it. Physically, if you go to a traditional data center and you try to install something like 5,000 machines in one weekend, it's not going to happen. It's not going to happen because you have to receive those machines, install the operating systems, cable those machines, and even if you have many, many guys, 5,000 is still quite a lot, right? So a lot of people have been talking about how cloud computing affected the IT industry. This is one of the reasons why cloud computing is so important, is because suddenly any startup that is successful enough can survive his own success and also, continue to operate at an extremely large scale. Because the business model here is that you only pay for what you consume, a bit like electricity, right? But perhaps the most important thing is not like being able to peak at 5,000, but after here, I didn't cut the diagram, but you can actually go down, so you can release the capacity when you don't need it anymore. And Pinterest have been doing exactly the same. So 2-3 years ago, the architecture was, something like 25 nodes, something like this. So last year, they had 80 million users. They go now above more than 600 terabytes of data. And the interesting thing, perhaps, is this one, is they only have 12 people operating the complete system, right? If you look at the pricing way, this was 3 years ago for Pinterest. Now it's a worldwide company, so you don't see the cycle anymore. So here is the hours, and you can definitely see that when people sleep, obviously they don't go to the website, right? Now Pinterest is a global service, so it's more flattened. But roughly 2-3 years ago, it was like this. And it was interesting because if you want to do it from a traditional perspective, we had exactly the same problem at Amazon.com and Amazon.es a couple of years ago, is that if this represents the amount of IT capacity that you need to serve your users, you have to provision above this. Because obviously the problem is that if you go under and you have more users, then your website is down, it's completely dead, right? And you definitely don't want that to happen, right? So you over-provision, which means that you're wasting money, right? You're buying too many servers, you're buying too much storage, too much bandwidth, just in case it's going to be way higher. But the thing is, you only need this capacity during the bulk of the day, like from 8 a.m. to 8 p.m. roughly, which means that here, this is where you're wasting money. Or conversely, by using Amazon Web Services, you only pay for what you use by the hour. So you have very important savings. So for Pinterest, the pricing per hour was like this. So 2 years ago, Pinterest was consuming $52 per hour and, roughly $20 per night, right? And this is interesting for a startup because it means that you can run your service and try to take risks without having to invest in long-term capacity, right? If you do it, if you look at it traditionally, and this is something that was interesting because when I started working with startups in Europe roughly 4 years ago, the investors didn't like us much. Because they say, hey, if people can go now with a credit card on Amazon Web Services and rent a couple of servers at this price, they don't need VC investment anymore, right? So what are we doing? Well, obviously, they quickly realized that, you still need VC funding for marketing and all these kind of things, but basically it allows you to erase the financial risk of your IT infrastructure. Because if you pay by the hour, if suddenly, unfortunately, your startup is not successful anymore, well, you just close it, and guess what? You don't pay for it anymore. So Instagram was also the same. I just wanted to call that out because Instagram, they're running on Amazon Web Services, and they only need 2 engineers to run a system that is doing more than 30 million users, right? So it tells you that if you can abstract the maintenance of your IT infrastructure, the size of the team of your startup today can scale up to those numbers, right? So Well, I don't want to go into the technical details. I'll quickly skip through this, unless the audience here is pretty technical and wants me to do it. But Amazon EC2 is a service that allows you to rent virtual machines, like virtual servers, by the hour, depending on the size and the pricing, which means that, as I told you, you have a variable cost depending on how much capacity you use. But also, it allows you to tap new business models, which is the one of temporary applications. So VisiWare is well, it's not a startup anymore. It's a company that is developing mobile applications for a popular game. I don't know the name in Spanish, but it's Who Wants to Be a Billionaire, or ¿Quién quiere ser un millonario? No sé si dice así. And the thing is, you have this mobile application and you can play with the TV show. So if you think about it, it means that for the guys in the UK, when they had this TV show, basically you need infrastructure only for 2 hours once a week. So it will be completely silly to buy servers only for 2 hours once a week, right? So this is the kind of things that we enabled, and especially imagine all the startups that have been also running the application only for the Olympic Games, only for soccer games, for concerts, and so on. Basically, it gives you the ability to have a complete IT infrastructure only for a couple of hours, only if you need it, right? So Amazon S3 is exactly the same, but for storage. I don't know if, I think Dropbox is pretty popular in Spain as well, right? So if you're using Dropbox, technically you're using Amazon. Dropbox is the backend system is on Amazon S3, right? And this is interesting because it's another interesting lesson for startups is sometimes startups tend to focus on too many things. And Dropbox is not in the business of storing your files. I mean, as strange as it is, it's not their business, right? They are in the business to allow you to store the files and to share the files with other users, right? But the storage of the files is done by Amazon. So the thing is, they have similar numbers as the one that I show. I think the operation team in Dropbox is only seven people. And by completely outsourcing the problem of the storage, they can focus on the real problem, which is making it easy for anyone to store a file in the cloud, right? So the second problem for mobile applications and for Internet of Things, we're going to see it later, is the distribution then of the application. So I wanted to quickly talk about the Amazon App Store for Android, because it has some nice twists. It's integrated on Amazon, so it's Amazon.com, but it's the same for Amazon.es. So you can buy directly an application from your Amazon account, and you have exactly the same thing, like the feedback of the users, the 5-star rating, and so on. The thing is, because you're selling on a store that is not only selling mobile applications, like what you can see in the other app stores, we have way more impactful marketing cross-selling campaigns. For example, here in Spain, someone goes to Amazon.es, he buys a T-shirt of the Real Madrid. I'm going to send him an email. I mean, if you already bought on Amazon, you probably already received many of emails from us. So if you buy a T-shirt from the Real Madrid in Amazon, you're going to receive an email that is going to suggest you also to check out a mobile application about the Real Madrid, right? So we do cross-selling opportunities not only on the physical goods we sell on the Amazon store, but also on the things we have on the App Store as well. So for the video games or the mobile games, this is extremely successful because you can definitely know, depending on the buyer profile, what are the type of games that this person will be more interested with. Another thing is that one of the problems we saw on the app stores is that people are reluctant to install an application on their phone if they don't know if it's going to be good for them. So you can go to the test drive here, and basically you have a virtual emulator on your web browser that allows you to use the mobile application and try it basically before you buy it. The last thing before I go to the platform is that today we're targeting the Android market, and one of the problems is the diversity of the platform. That is, there's multiple devices for everything. We have our own series of devices. You probably heard about the Amazon Kindles. We have also the Amazon Fire Phone that is for the moment only available in the US, Germany, and the UK. It's coming for Spain as well. The thing is, the Kindle Fire has been one of the most successful tablets in the US. It's also raising a lot in Europe. It goes above to more than 25% of the market share. And the interesting thing for you who are developing an application, perhaps for Android, is the monetization part of it. How do you make money with the application? So there's no video now anymore. Okay, thank you. So the thing is, because it's an app store that is managed by Amazon, the monetization part is handled by Amazon Payments, which means that anyone who has an Amazon.es or an Amazon.com account can buy on your application. And it changed into this because if you look at the statistics, this is a use case of one of our recent customers, but we see it pretty much across all the applications. The monetization or the transformation of the selling on your applications is way higher on Amazon. And there's many reasons, but my interpretation is that, and when I discuss with the users, is because people who already bought on Amazon, they already have the credit card on Amazon, and they already have the experience to buy online, so they are more able to continue to buy online applications compared to other users who never bought anything online. So basically, by selling your application on the Amazon App Store, we give you access to all the Amazon.com customers or the Amazon.es customers who are people who already buy online, right? So those are people who are definitely more able to buy virtual things on your applications. So a couple of case studies. I'm running a bit out of time. So Flipboard, not sure if it's popular here in this side of Europe. It's a social magazine. They started just as an RSS aggregator. Now they basically the point of the application is to give you access to an RSS feed and then to understand what are the most successful articles or what are the articles that are read depending on the people, right? I don't think I have it here, but I also wanted to share a story of a company that started a couple of years on Amazon Web Services. The name is Onavo. The activity of the company was to sell a small application you install on your Android device and on iOS, and it compresses everything that runs through the network, a bit like the BlackBerry were doing like 2-3 years ago. So you save on your BL. And the thing is, they didn't have any way to monetize the application, right? So because the application was for free, exactly like Flipboard. So what they do monetize, they've been acquired last year by Facebook. I think it was close to something like 100 million, something like that. But anyway, what was interesting here, like Flipboard you install it for free, is to give you the access to the data of what people actually saw on the application. So Flipboard, for example, can sell this data to newspapers like El País to give them an idea of what are the articles people will actually read in El País and what are the others one that people will absolutely not care, right? And if you look at the way newspapers are done today, if you look at online newspapers like the Huffington Post, basically the titles of the articles that you are going to read are A/B tested depending on your profile. So for the very same article, they are going to test different titles just to see what are the titles that generate more clicks, right? Because at the end, I mean, when I'm an online newspaper, I'm interested to print ads, right? And I print ads only if people watch my articles. And people watch my articles only if the title is good enough. So this is the kind of processes people have been doing on it. Foursquare is another geolocalization application that also runs with Amazon Web Services. Here, one of the concepts was to be able to push notifications depending on the location of the people. So this is something that can be done pretty easily as well. There's a service dynamic for that. Instagram, I think we already talked a lot about it. Here, the problem was more storage. That is, when you're starting to store a lot of pictures, it's difficult to predict how many users you are going to have, and especially the elasticity, how quickly you have to add a capacity for the storage. One of the nice stories of Instagram, I remember 3 years ago, Justin Bieber created an account in Instagram. Right, and automatically they were able to add more capacity, a bit like Animoto, because they definitely predicted that if someone like this has a public account on their application, there's going to be a lot of traffic. So perhaps the most interesting applications are the ones that actually start using the power of the cloud computing platform, because for the moment you see applications that are, let's say, pretty straightforward and use very classic services. So Autodesk, for those of you who don't know, it's a well-known software company for architects and industrial designers. And now they started to be more engaged in the business of the 3D printing. So they have these 3D printer MakerBot. And interestingly, they move their application, Autodesk, in an online application, which allows you to, from a browser, to build the models, and then they print them and then ship them back to you. So it was only in the browser, and now they move it to a mobile application, right? So what do you do to have like a 3D modeling application in a mobile? The screen is too small, right? So they did this application, which is basically you take pictures of an object by turning around it. They send those pictures on the Amazon backend, and then we are regenerating the 3D model based on the pictures that we had. And then this 3D model gives you an object that is completely scanned from a mobile phone, right? So this is the kind of applications that definitely you cannot do on a mobile phone, because even if mobile phones are powerful today, they don't have enough CPU power to do this kind of calculations, and that are enabled by the cloud. And we see exactly the same thing now for the Internet of Things. So I'm just keeping track on time. So when we talk about Internet of Things, there's the classic thing that people think about is smart city sensors, pollution detection in the city, and these kind of things. I just wanted to share quickly this use case, because interesting scenario. It's called the glow cap. So basically, the capsule is going to glow, blinking lights and sound when you need to take your medicine, right? And basically it starts remotely. Your doctor, when you go to see your doctor and he tells you, for example, okay, you have to take those pills twice a day or once every week, he's going to have, with the application, he's going to be able to control how the cap is going to glow, because he has access to your account, right? So the thing is, it allows this kind of change in the behavior. So each line here is a person, and every time you see a red dot, is a person who didn't took the medicine on time, right? So you see, this is especially true for older people. They frequently forget to take their pills. So basically here, if you see those users, right? I mean, they went to the doctor, they pay for the medicine, but it's not going to do anything good for them, because they simply forgot to take the medicine, right? And by having this glowing thing making sound and reminding them that, hey, you need to take the medicine, it turned into this, right? It's not a mobile application. It could be a mobile application that sends you an SMS, right? But they did it with a cap, because when you open it, then you know that at least when they open it, the chances are they also took the pills, right? If it was a mobile application or just an SMS, perhaps the person received the SMS but just didn't care. So you have to know that the person took the pill, and this is when you are going to open the capsule here, that it sends the signal that, well, yeah, they took it in on time. So this is a classic Internet of Things scenario where you have a device, which is the capsule, that has very low powerful or CPU power, processing power, or connectivity, but that can give you sensor information that then you're going to aggregate into an analytics tool. So Illumina is another example that it's, what they're doing is they scan human DNA, or basically any kind of DNA. So this machine has roughly the size of a big printer, right? It costs something like $5,000, and you put a cell sample, and in less than 1 hour, the machine is going to completely scan the DNA of the cell and upload it to Amazon S3, the same service that is used by Dropbox. So it allowed them to build a complete backend system, software as a service, that allow the biologists to do analysis on the DNA, pattern recognition, and this kind of processes. So the thing here, what's interesting is if you go back to the 90s when the Human Genome Project started, it took us something like 15 years to scan the first human DNA. it cost something like $7 million. And now this is something that you can do in just less than 1 hour for $5,000, right? Because the IT capacity you have to do this kind of analysis is virtually limited. Now IT is not a problem anymore, right? So another example on this, and then I'm going to show you a couple of architectures, is a Dropcam. So Dropcam, basically, they made a better webcam, right? So it's a connected camera that is going to flow the video content directly to your account. So you're going to be remotely able to see and to control your camera. It works through your mobile device, through an internet connection. So with a mobile device, you can see what your camera is currently filming on your home or whenever you put it. And the thing is now, Dropcam is generating more inbound traffic than YouTube, right? They're extremely successful. Well, perhaps especially more in the US compared to this side of Europe. But now the upload rate of video flow coming from Dropcam is way higher than what you can have. So this is also one of the things is when you work on Amazon Web Services, the inbound incoming traffic is for free. We don't charge you for this. So it enables you these kind of business models where you can virtually update like petabytes of data and you only pay for the storage. You don't pay for the upload bandwidth. So now to go quickly perhaps on the technical part, from an architecture perspective, it always looks like this. So you have your devices. Sometimes your devices are not powerful enough to establish a proper internet connectivity, especially if you look at HTTPS connections and so on. So they're going to go through proxies. In the case of Dropcam, they have, for example, your Wi-Fi router to have the internet connectivity and to upload the data on your application. And what's interesting is here, I'll go back to this side, because you always have one side of the application that collects data, think about your Fitbit, and another one that will allow you to interact with the data that you collected. So from a technical perspective, I'm sorry if people are not too technical here, but basically you need to authenticate yourself on a first service, and then it's a little bit like web applications. You go directly into a queuing service. For people using MQTT, it's roughly exactly the same, but with load balancers. And the backend is a large-scale data analytics systems. So it can be either a Hadoop cluster or data warehouse system. But the interesting thing to keep in mind here is that in one side, you have systems that are pushing data, and another side, your users and your mobile application that is consuming data, right? So if you want more technical details, I'll still be here, and our booth is just across the aisle, so we can talk about the technical details here. But my point is that it's all about having sensors. Think about the glow cap or like the Dropcam, and analyzing the data. So at the end, what I was telling at the beginning is that IoT goes hand in hand with mobile, because IoT is used for sensor data to capture the information, and the mobile application is also used to allow you to visualize the information. So those are the both sides of the equation when you create these kind of systems. The classic example, which I think is a bit silly, right, is the connected toothbrush, right? So this is a toothbrush that, believe it or not, is showing statistics of how much time and how well you are brushing your tooth, right? You can even share that with your Facebook friends. I don't know if it's really helpful, but anyway, it's the classic example of here. You have a device that doesn't have enough power to connect to the internet, and is going to use your mobile device to upload the data, right? This is something that we see also a lot when you have smart meters. I don't know if you follow the news, but even in Spain, Fenosa and Endesa and a couple of other companies try to push for smart meters. And the way they did it is people reacted pretty bad, because they say, well, you're trying to have access to personal information that is mine, how much electricity I consume, and so on. So in the Nordics and in the UK, they turned the problem in another way. They say, okay, we're going to install a smart meter in your home, but we're going to give you access to this information for you with a specific application. So basically, we give you a mobile application that is telling you in real time how much your house is consuming and so on. So they give you tips on how you can reduce your costs. And now it's going to it's picking up, and I saw a couple of projects that are going to come back now in Spain as well with exactly the same thing. So you see again exactly the same kind of pattern. Somehow you have your smart meter, which is the sensor, which is uploading data to a cloud infrastructure. And from the user perspective, you have a mobile application that allows you to get access to the data. Just one thing also, which is now getting some traction for the mobile applications, is mobile tracking. So for the technical people here, when you move around with your mobile phone, basically your mobile phone is sending information to an antenna to get access to internet connectivity, and basically the information that is given to the antenna roughly can allow you to fingerprint a mobile phone, not a person, but a mobile phone, right? And basically it allows you to identify uniquely a mobile phone, which from a marketing perspective, you can use it to see if people are close to a specific shop and so on, or if a specific mobile phone goes to which specific shops, right? So it's basically the same thing as HTTP cookies for mobile applications. And you see it used in now by cities to have an idea of the concentration of people. If, for example, the town of Madrid had this system, they will see a high concentration of mobile phones in this area, right? So it will allow them to like dispatch public service like police, firemen, and so on to high concentrated density zones, because they know that there's a lot of people, so the risk of having a problem is higher, right? And in some countries, there's also this test, because antennas are also available in highways. So if you know the time where a mobile phone goes through an antenna and you know the distance between the two antennas, I mean, you know the speed, right? So the system is not to send you a file directly on your mobile phone, but it's just used today to understand where you have traffic jams. Because if this is a highway and the distance is 1 kilometer and you see that people need 1 hour to go from one antenna to another, you definitely know that there's a problem there. Okay, so it means that you don't need to buy new complex hardware and new complex sensor infrastructure to get this information. You can already get this information through analytics of existing sensors. So it was just to say that now the antennas of mobile phones and Wi-Fi routers are also used as sensor data. So one last cool project I wanted to mention that has been running on Amazon as well is the Copenhagen wheel. So for those of you who travel to Copenhagen, you already know that it's the countries of the bikes, and they pioneered the concept of renting the bikes to travel on the city. In the rear of the bike, you have a bunch of sensors, noise sensors, carbon monoxide sensors, nitrogen sensors, and so on. So the idea is they want to have pollution information about the city, but basically when you want to do this kind of project, you have two options. Either you install sensors yourself everywhere in the city. It's expensive, it takes time, it requires cabling and access connectivity, or you have a sensor that you move around the city, right? So some countries, for example, I think in Salamanca, they put the sensors on top of the buses. So when the bus is traveling across the city, you have the information that is captured by the bus path. But it only gives you a spread of information only where the bus go. Here, by putting it on a bike, you have a way better mesh of information because the bikes are going to many other places. So again, it's a bit like the smart meter. You have to motivate people to take those bikes and to move the sensor around. So what they build is a mobile application, again, that basically allows you to, gives you the information on where you've been. So they give you back your information, exactly like the smart meter that I showed before. And here we go. And you can also have back access to this information. And when they aggregate everything, they produce these kind of visualizations that, for example, show us the peak of pollution in some parts of the city. So this is nitrogen monoxide. So basically, the project you see here is, again, sensor data that you aggregate. But to motivate the collection of the data, you have to give the data back to the user who produced it. And then by aggregating the information, that's when you have good insights, right? So more and more you will see sensors that are replaced by mobile phones. If you saw the latest brand of phones, you know that mobile phones now have pressure sensors, they have accelerometers, they have compass, and so on. The next generation of mobile phones, they also have pressure and temperature sensors. And well, we already see that many applications like the one that Amazon has that allow you to scan a barcode and to get a price. Now, even without scanning a barcode, with the Amazon phone, you can just film a book, and we're going to recognize the book and point you to the right page on Amazon. So the thing is, even you see that with companies that is not the business to sell online. So this is an insurance company. I think they already exist also in Spain. It's Direct Plus. So they do on-demand insurance. So for the insurance of your car, every time you're going to take the car, you turn on your phone and with the application, you press the start button. The application is going to follow you and time how much time you're using your car. And then you're going to pay the insurance only for this amount of time, right? Now the thing is, they also know the GPS location. So they know where you've been. If you stay in Spain, so the insurance is only for the Spanish territory. If you travel in France, then you're going to pay an extra because you're going across the border. And they know if you are driving well, right? Because if you have my GPS information and I'm traveling in a city at more than 50 kilometers per hour, my insurance cost will go higher, right? Because I'm not driving well. And but anyway, this is kind of another side effect of capturing this kind of information. But also, it allows you what I mentioned earlier, to have applications that run for what in the past required to have a long-term contract. Now you can have applications that allow you to focus on short-term contracts. I mentioned Fitbit, but you can have exactly the same thing just by using your mobile phone. So this is an application called human.co. So they use the accelerometer of your mobile phone to detect if you are sitting, if you're moving, if you're running. And the interesting thing is that sometimes it's more proper to have your mobile phone always with you compared to your Fitbit device. So it works extremely well as well. So just to quickly finish, the idea so far is for many startups, is to collect, process, and display the information. But what is happening right now is you probably heard that machine learning is a hot topic in IT. Now people are moving to collect, process, and learn about the data, right? So what I just mentioned about the direct insurance, they learn about the patterns of the drivers, if they drive well or not. In Spain, there's another interesting project that there's a network of sensors that are displayed in a forest. Those sensors have temperature, humidity, wind. And depending on the past history of fire in the forest, they are able to understand what are the patterns that lead to risk situations. So they can predict the zones where you're going to have a higher probability of having fire. And last point is to be able to collect, process, and act on the data. So this is definitely the field of robotics. One of our customers in France, they're already doing this. It's Aldebaran Robotics, so they showcase in the summit in Paris those robots. They have roughly like 1 meter tall. And obviously those robots don't have enough CPU power to take decisions, to generate the sounds they need to do, to capture the sounds, to talk and so on. So they are connected to the Amazon cloud. They have cameras and they have microphones, so all the sensor data is uploaded to the cloud, which processes the information and tells them what you need to do next. And by the way, this is a pretty similar use case to what the NASA is doing. The NASA is also using Amazon Web Services for processing the images and the data that is sent by Mars rover, which here doesn't happen in real time, but just because of the distance. So for the conclusion, what I wanted to highlight here is that with Amazon, we give you 3 main pillars for your application. The backend infrastructure, right? All the components that allow you to build a scalable and elastic backend infrastructure. The distribution channel, we saw that with the App Store. And the application platform itself, right? So the main points that I wanted to make here is that for many startups, the whole objective is to be able to focus on your business and to decide what are the things you are not going to do. So focus on your business and focus on your users. So with that, thank you so much for your attention. If you have questions in Spanish or in English, I'll be glad to hear them. Thank you.